Hi, Shireen will be taking up trigonometric identities involving the ratios of complementary angles. I hope you remember the the complementary angle formulas. I take up the first one, which is to be proved as. Oh, I'll just use some other color maybe. Or it's black fine? Yep. Okay. Let me continue with it. It says sine 90 minus theta cos 90 minus theta by tan theta is equal to 1 minus sine square theta. Once we have to prove, let us take it up from the left side. I say this is a very simple one. Sine 90 minus theta gives you a cos theta. Cos 90 minus theta gives us a sine theta. Tan can be written as sine theta by cos theta. Now, if I reciprocate it, I'm getting a sine theta cos theta, which was there already, and now reciprocating this denominator, I get a cos theta by sine theta. Oh, was there a minus symbol? No. So this is equal to, I'm getting this cancelled. So this is cos square theta. Now cos square theta plus sine square theta is 1. So cos square theta can also be written as 1 minus sine square theta. Wasn't this very simple? Okay, let me take one more of proof and then we move on to the evaluation of complementary angles. Which one do I take? Okay, I take another one here, that is cos square theta, cos square 90 minus theta minus tan square theta, is equal to cos square 90 minus theta plus cos square theta. Yeah, I've written it rightly. Now cos square 90 minus theta, what is it? Cos 90 minus theta, that gives you sec theta. So this becomes sec square theta minus tan square theta. What is sec square theta minus tan square theta? That is 1. So this side we get 1. Now look at the right side. Cos 90 minus theta is what? Sine theta. So cos square makes it sine square theta. We already had a cos square theta, so that makes sine square theta plus cos square theta as well 1. So we see left hand side is equal to right hand side. These are the kind of proofs we get under trigonometric ratios related to complementary angles. Now we move on to certain evaluation. I'll just write down the question. The question reads like, without using the trigonometric table, evaluate the following. So you will be applying this complementary angle values. I am not taking a too kind of difficult question first, then I can move on with more complicated one. Okay. Oh, sorry, I write it as 20. It will be, theta, it will be 20. Sine square 20 degree plus sine square 70 degree. I'm not giving those degree symbols just to be able to write it fast. So cos square 20 degree plus cos square 70 degree plus sine 90 minus theta into sine theta by tan theta plus cos 90 minus theta. God, too long a question for me to write. By cot theta. We have to find a value of this. Now in the left hand side, I continue here with the solution. I'll write it here. Now sine square 20 plus sine square 70. I have to change it in a common to a common platform wherein I can apply the identities. So I'll change sine square theta, and this can be expressed as sine square 90 minus theta, so that makes it sine 90 minus theta. That gives me 70. Herein I will be keeping it as it is, plus cos square 70. Do I need to keep it same, or I also need to change, because that also needs to be 1? Okay, so this can also be written as 90 minus 20. So it is sine 90 minus theta, cos 90 minus theta, plus it is already sine minus. Let me just write the rest of them as it is. We don't need to change much in that. This doesn't, it's sine theta by tan theta, and here it is cos 90 minus theta with a cos theta by a cot theta. So here what I get, sine square 20 degree plus cos square 20 degree by cos square 20 plus sine square 20. It always comes as theta, you know. So that is 20. Now here sine 90 minus theta can be written as cos theta into sine theta, and this tan can be written as sine by cos, and that makes it cos by sine. I'm doing it in the same step. You can carry on with one step wherein you convert this tan as sine by cos, and then in the next one you can make this reciprocal noted. And here this cos 90 minus theta gives you sine theta, and thereby convert this into reciprocal, which is cos by sine. It is sine by cos. See, this getting cancelled, this two getting cancelled. Here in sine square theta plus cos square theta by cos square theta plus sine square theta, this whole one sorry, plus this is a cos square theta plus there is a sine square theta. So now again cos square theta plus sine square theta, that gives you 1. So it's 1 plus 1, that is 2. Now let us move on with taking up another question on a similar note. That might not be as difficult. I'll not be taking up that difficult question, you know. Okay, let me just write down the question first. It will be minus tan theta cot 90 minus theta. Tan theta cot 90 minus theta plus sec theta cosec 90 minus theta plus sine square 35 plus sine square 55. This whole is by, don't go by this tilted line a bit, tan 10 degree got tan 20 degree, tan 30 degree, tan 70 degree and there is a tan 80 degrees. How we take this up? Take this question up. See, minus tan theta, let it be minus tan theta. Now cot 90 minus theta. What is cos 90 minus the cot 90 minus theta is tan theta, so it becomes tan theta plus sec theta. And what is cosec 90 minus theta? That is again sec theta. So we are all getting squared. We are all getting squares plus, now this is sine square 35. If I get a cos square 35 therewise, that will help me to get a 1 there. So sine square 55 can also be written as sine square 90 minus 35. Yeah, that is giving me a cos square. And let the whole by, now tan 10 degree, tan 20 degree, then there is a tan 30 degree, and tan 70 can also be written as cot. No, I can write that as cot. Yes, I'll get it a cot. So tan 90 minus 20. Similarly, I can express this as tan 90 minus 10, because that's then going to cancel certain values. Okay. Now tan theta, but is a minus, so it is minus tan square theta. Similarly here it will be sec square theta. And now here I'm getting sine square theta was already there, as because I applied the complementary angle there. I'm getting a cos square 35 as well. And here in the denominator I'll get a tan 10, I get a tan 20, I get a tan 30, and this tan 90 minus 20 becomes cot 20, and tan 90 minus 10, that also become a cot 10, right? Now look at the numerator. I can simply rearrange the writing, so it becomes sec square theta. It becomes sec square theta minus tan square theta, and this one will be put into a bracket, and the rest is again sine square theta plus cos square theta, that was giving a 1. And the one below, let me just write it, manage it within the space there. See, it is tan 10 and cot 10, that gives you 1, right? Then tan 20 cot 20, that gives us another 1, and there is a tan 30, and there is a tan 30. What's the value of tan 30? If you recall the table, this here sec square theta minus tan square theta, that as well is 1. So it is 1 plus 1 by 1 into tan theta, if I recall correctly, will be 1 by root 3. So we are getting this as 2 by 1 by root 3, so that makes it this by 1 by root 3, so that makes it root 3 2 root 3 by 1, so that is 2 root 3. This is our answer to this whole big one. Thank you.